These are the 6-5 notes, and the 6-5 notes kind of just make a summary of everything that we've learned so far in this chapter. We've learned about several different ways to solve systems of equations. We've learned about graphing in 6-1, substitution in 6-2, elimination using addition and subtraction in 6-3, and elimination using multiplication in 6-4. Now, 6-5 just takes those methods and says, I'm going to give you the system of equations, you decide which one is the best way to solve these. And so I made you a little table on the front of your notes. I broke them down by section. So graphing was 6.1, substitution was 6.2, elimination and by addition and subtraction were from the same section. They were both from 6.3. I put them separate on here so that we can see when it's appropriate to use either one. But I think you know if they're the same sign you subtract, if they're opposite signs you add. And then 6-4 was elimination using multiplication. So here are some of the pros and cons of each of these. When you're graphing, sometimes you're not exactly perfect when you draw in your lines. And so it's a really good estimate of where the solution might be, but unless you do an absolutely flawless job and there's no decimals or fractions, you can't really get a perfect picture of where your solution is. Graphing is pretty rarely the best way to solve systems of equations. Substitution is great if either of the variables has a coefficient of 1 or -1. The only time that I really like to use substitution is if one of the variables has already been solved for. Elimination with addition or subtraction is if they have matching coefficients, and if they are opposite signs, you add. If they're the same sign, you subtract. And then elimination using multiplication is if you don't have the coefficients of 1 or -1 and they don't match up, then go ahead and use that last method. So go ahead and turn to the next page. On the top, I tell you that in general, graphing can be a good way to estimate a solution, but estimation is pretty much where you draw the line. It's pretty rarely going to give you an exact solution. So substitution and elimination are usually the best ways to find it. We've talked about this before in class. I prefer elimination. I think it's a little bit easier. You guys seem to agree. If you feel differently, feel free to use substitution. That's just fine. Let's go ahead and do this example. We have 4x minus 4y equals 8, -8x plus y equals 19. They say choose one. Now, based on this one has a coefficient of 1 for its y. If we went off the table on the front, it would say use substitution. I'm going to let you choose here. I'm going to go ahead and use the substitution that they suggest. If you think that you would rather do it using elimination with multiplication, go for it. I'm going to stick with substitution. So over here I have -8x plus 1y equals 19. They say get the y alone. I'm going to add the 8x, and now I have 1y, or let's just say y, equals 8x plus 19. And now I can just substitute that into the first equation. So I'm going to say 4x minus 4 times 8x plus 19 equals 8. This is another disadvantage for using substitution is you're going to have to distribute those numbers, and sometimes when you do that, you're going to start getting big numbers like 4 times 19. And that's not that big of a number, but it's a number that we don't know off the top of our head, so we have to start using calculators and double checking our work, and that's one of the disadvantages of substitution. So go ahead and distribute. I get 4x minus 32x plus 76 equals 8. This should be minus 76, I'm sorry. It's a -4 being distributed. 4x minus 32x is going to give me -28x minus 76 equals 8. Add that 76. I get -28x equals 84. Divide by -28. I get 3. X equals -3. Now I'm going to take that x and I'm going to plug it in up here. I'm going to say y equals 8 times -3 plus 19. Y equals -24 plus 19 gives me -5. So my ordered pair is -3, -5. So it's not that difficult, but I feel like it's a little bit more work than elimination. If you used elimination, did you get the same answer? If you didn't, go back through and see if you can get the right answer. All right, there are, let's see, 1, 2, 3, 4 more examples in this packet. I'm going to let you go ahead and try all 4 of them on your own. Choose which method you prefer or what you think will work the best for each of these. Just write it on the page. So like for B, if you're choosing elimination, say elimination and then go for it. You should pause the video, try them, and then come back to it when you're ready. I'm going to go through the rest of this packet right now. So I'm taking a look at this example. I see that my 7s match up. I'm going to just use elimination with addition or with subtraction because they have the same sign. So I'm going to subtract. 5 minus a -2 is the same thing as 5 plus a positive. 7x equals, 7y is canceled. 2 minus 9 gives me -7. Divide by 7. X equals -1. Plug it in. 5 times -1 plus 7y equals 2. -5 plus 7y equals 2. Add the 5. 7y equals 7. Divide by 7. Y equals 1. My ordered pair is -1, 1. I chose elimination. If you chose something different, did you get the same answer? You should have. It doesn't matter what method you use, you should still be getting the same answer. All right, letter C has x and 7x, -y and +y, 9 and 7. These are the same. They have opposite signs, so all I have to do is add them. X plus 7x gives me 8x. The y's will cancel, equals 16. Divide by 8. X equals 2. Plug it in. 2 minus y equals 9. Subtract the 2. -y, I'm going to say -1y, equals 7. Divide by -1. Y equals -7. My ordered pair is 2, -7. Again, I just chose elimination. Okay. Turn to the next page. Okay. None of these have a coefficient of 1 or -1, so substitution's out the window, but they don't match up. So I'm going to have to use elimination with multiplication. So I'm going to go with the top one. I'm going to make the 4 and the 8 match, which means I just have to multiply the top one by 2. So I get 6x minus 8y equals -20. 5x plus 8y equals -2. That one stayed the same. Now I have my 8s that match, but they have opposite signs, so I will add 6x plus 5x gives me 11x. The 8s cancel, equals -22. Divide by 11, x equals -2. Plug it in. So I'm going to say 3 times -2 minus 4y equals -10. -6 minus 4y equals -10. Add the 6. -4y equals -4. Divide by -4. Y equals +1. My ordered pair is -2, +1. All right. I use elimination. Again, I'm not going to put in by multiplication because essentially they're the same thing. They're just elimination. And then the next page, we have the last example. Now, one of these does have the coefficient of -1, so we could use substitution like they suggest. I'm going to choose elimination because we prefer it. And so the 5 and the 3 don't match up. The -1 and the 2 don't match up. We have to choose one of them to make them match up. I'm going to go with the top one and make the 1y a 2 to match the bottom. So I get 10x minus 2y equals 34. 3x plus 2y equals 5. Now they match up. They have opposite signs, so I have to add. 13x, these cancel, equals 39. Divide by 13. X equals 3. Go ahead and plug it in. 5 times 3 minus 1y equals 17. 15 minus 1y equals 17. Subtract the 15. Negative 1y equals 2. Divide by negative 1. Y equals negative 2. My ordered pair is 3, negative 2. Okay, so I used elimination here again. Now, if you do not like elimination, you do not have to use it. You can use substitution if you would rather. You should get the same answers, though. Okay, those are some short notes. That's the end of them. Go ahead and take a look at the homework. Email me with any questions or come see me. I will see you tomorrow in class.